Hello.
Hello.
Yeah, can you hear me?
Yes.
Okay. We'll continue with number theory. The first question that I want to discuss is, I don't know whether we've already done it, but we'll check this out. For some positive integer n,
Uh-huh.
the number 110, the number 110 NQ
Yeah.
has 110 positive integer divisors.
Yes.
You have to This includes the number 1 and 110 and cube includes them. You have to find how many positive integer divisors does 81 n power 4 have. Uh, the options are 110, 191. Okay.
Okay. So you can say that 110 is prime factorized into 2 times 5 times 11, So then 110 n to the power 3 is equal to 2 times 5 times 11 times n to the power 3.
Mm-hmm.
But from there, we don't know that n to the power 3, n is prime itself. So we don't know if there's prime factors in n.
Yeah, we don't know it.
Yeah. When n is 1, you get 8 factors, but then when n is 2, you get
You cannot start from n is equal to 1 and start checking numbers.
yeah, because that's
You
not
have
a
to
zero.
you have to think of some strategy to look at what information can be obtained from this many divisors.
There's 3 divisors in there, so
Can the number n have 4 prime factors? Or can the number 110 n cube totally have 4 prime factors?
uh yeah, if n is like 7 or something.
Is it possible to have 4 prime factors and have this many divisors? If you have a number like the P1 power K1, P2 power K2, P3 power K3, P4 power K4, how many divisors will we have?
K1 plus 1 times K1, K2 plus 1 times K3 plus 1 times K4 plus 1.
Is that how many divisors? How many divisors do we have?
Oh, okay. So there's only three prime factors.
There are
So
already three prime factors in 2 and 5 and 11.
yeah,
What should n cube have? Can it have any other prime number in it?
no.
It's obvious from there how to get this many. You can easily get n cube.
So then, since it's like n to the power 3, n is like some 2 to the power. So let's say n is like 2 to the power a times 5 to the power b times 11 to the power c. So n to the power 3 is all of that, but like also to the power 3. So 3a, 3b, and 11c. So then when we do that, you then just you can then say that like the product of these, so 110 times like n to the power 3 would be like your 11 times 5 times 2 times like the 2 to the power 3a times 5 to the power 3b times 11 to the power 3c. So then you'd say the total number of factors would be like 1 plus 1, so like 2 times times 2 times 3x plus 1 plus times 3y plus 1 times 3z plus 1. And that should equal your 211. I mean, not 211, 110.
What are the number of factors for this number right now? Number of divisors.
3a plus 1 times 3b plus 1 times
That's
3c plus
wrong. Who will add 1 to it?
1. Oh, 3a plus 2 then. 3b plus 2, 3c plus 2.
What is ABC?
So then you'd say that A equals 0, B equals 1, and then C equals 3. So then you have your N as 1 times 5 times 1, 3, 3, 1. Yeah. And then you just, oh, and then you plug it in. So 81 is,
Find the answer. Don't tell me the steps. I know the steps.
okay. 325.
What is the, we have done the theory for this. What is the product of divisors of n? N?
Uh, the product of divisors of n.
You had made notes in the previous class that we did. We have discussed this.
Yeah, I made notes. One sec.
Product of divisors of n is n to the power dn by 2, where dn is the number of divisors of n.
Yeah, I wrote like it's like half the number of divisors, like n to the power of half the divisors.
From that information, you should be able to find n here. They have given you the number of product of divisors. So they have
Yeah.
given you n power dn by 2 is this.
Okay. Wait, yeah. Wait, so I got that. So you have the number of divisors is 28 because like 7 times 4. And then so you get the product is like n to the power 14. So n to the power 14 is equal to
I don't know.
1728.
Okay.
But that's not a perfect like 14th root, I don't think. Because 2 to the
Why are
power
you
6.
calculating the values of these? Like, what is the benefit of finding the numbers and the values? Like, is it very important to calculate the numbers and do it?
No, but like,
N to the power dn by 2 is this, n to the power dn is 2 power 12, 3 power 6. I don't know what the problem is.
oh, I did it the like a like the opposite way. I said that. Oh, wait, never mind, never mind. I got confused. Okay.
I don't know why you are calculating number of devices of this number. That's how you get 28.
Yeah, that was my mistake. I got that n is 12.
How?
So what I did, so you have like that n to the power dn is equal to like 2 to the power 12 times 3 to the power 6. So what I did, I just said that let's say like n is equal to some like 2 to the power like x times 3 to the power y. So then dn is going to
How
be
do you know
equal
it doesn't have other prime factors?
because like you're saying that n to the power dn is something, so that dn is only going to multiply onto the powers of n itself. So if you have n is equal to, if you're having that like 2 and 3 there, you can't just like add in another prime factor.
Okay. Then what?
So then you get that dn is equal to like x plus 1 and then times y plus 1. So then you like plug that in. So you say like 2 to the power x times 3 to the power y. All of that to the power of x plus 1 times y plus 1 is equal to like 2 to the power 12 times 3 to the power 6. So, yeah, and then you multiply those exponents. And then Yeah, and then you make the exponents equal to the exponents on the other side. So x times x plus 1 times y plus 1 is equal to 12, and then y times x plus 1 times y plus 1 is equal to 6. And then what you do, you like kind of like cancel them out by dividing them. So you get that like x over y is 2, and then yeah, and then you get that x is equal to 2y and you plug it back in. And then when you do that, you get that your y is going to be equal to 1. So then your x is 2. So then yeah.
Okay.
And
Next one is how many positive integer divisors of how many positive integer divisors of 2004 to the power 2004 are divisible by exactly 2004 divisors. 2004 positive integers. You have to see the divisors of this number and then see how many of them have 2004 divisors.
yeah. So you have that 2004, like its prime factorization is 2 times 3 times 160, sorry, not 2 times 3, 2 to the power 2 times 3 times 167. So then 2004 to the power 2004 is going to be 2 to the power 4008 times 3 to the power 2004 times 167 to the power 2004. So we can say like one of these divisors is like n. So then you would say like n is equal to 2 to the power a times like 3 to the power b times like 167 to the power c. So then the number of divisors of this n is like a plus 1 times b plus 1 times c plus 1. And we want to get that to equal 2004. And then we already know that 2004, it's like prime factorization is 2 squared times 3 times 167. So a plus 1 times b plus 1 plus c plus 1 has to be that in some way. So then you have like the possible values for like each of these are like going to be either 2, 3, and 167. So you could say like one possible combination would be like 2, 2, and like 501. So you have like a plus 1 is 2, b plus 1 is 2, and then c plus 1 is 501, which gets the 3 and 167. And then you have like multiple ways like that. You have then like 2, 3, and 334. Then you have like 2, 6, and 167. And then you have like 3, 4, and 167. So you get these like four ways. And then because you have like different ways to put up the order, you like get the permutation of it. So for 2, 2, and 501, you have three ways to do that because two of them are the same. And then you have six ways to like do the other ones because all the numbers are different. So then you get like 21 solutions because you get 3 plus 6 plus 6 plus 6. So 21 is what I got.
21 is not right. There's more.
Maybe I'm missing. Yeah, I'm probably missing something. Let me check. Hmm. Mm.
For the power of 2, there can be two different ways to make it. It can be that all the powers of 2 are coming from 1, or it can be that powers of 2 are coming from two different numbers, right?
Yeah.
If all the powers of 2 are coming from one of them, there are three ways to do that. It could be either a plus 1 or b plus 1 or c plus 1.
Right. Yeah.
If all the powers of 2 are coming from two separate numbers, that also there are three ways.
Right.
Total number of ways to put the powers of 2 are 6 ways.
Yeah.
For powers of 3, it is 3 power 1. There can be only one 3 somewhere. There will be three ways to do that, either here or here or here.
Yeah. Right. And then same for 167. Oh, so. Oh, okay. Okay. I see.
There are 6 into 3 ways
Yeah.
to make it happen that this product will be equal to this.
Right.
That many divisors will be there which have exactly 2004 divisors.
Yes.
Okay. Uh, you have to find the number of divisors of n squared that will be smaller than n, but they don't divide n.
Yeah. Wait, is that 2 to the power 3 factorial?
2 to the power 31 and 3 to the power 19.
Oh, okay. I thought the dot below was like an exclamation mark. Well, n squared would be 2 to the power 60 yes, 2 to the power 62 8. So then the number of factors of that would be like, um,
Are you getting an answer?
yeah, I got 589
Why?
because so you have like the n squared factors, the number of divisors. So you want to get half of that because those are going to be the factors of n squared that are like less than n because half is greater, half is less because it's n squared. So then you get like 63 times 39 divided by 2, which is going to be like 128, 100, yeah, 1228. So then and then you get
63
that
times 39 should be odd. How are you
63.
dividing by 2?
Wait, I did 63 times 38. Oh, I forgot to add 1 to it. Never mind. Wait one sec. Oh, wait. No. Okay. So I did 63 times 39, but then I subtracted like 1 from it because one of those is like n. So then I did that. So that's how I got 63 times 38. And then I divided that by
How is
2
that 63 times 38?
because you're doing 39 minus 1.
Is it 63 times 39 minus 1 or 63 times
Oh,
39
wait.
minus 1?
That's so silly of me. Wait, never mind. One sec. I did the PEMDAS wrong. It's the first one. So 63 times 39. Yeah, so then you get 2, 4, 5, 7 minus 1. So that's 2, 4, 5, 6. And then that divided by 2 is 128. 1228. Yeah, and then when you get 1228 from there, that's how many are like less than n. So then when you do the number of factors of n, you do 32 times 32 times 20. So you get that, but then you also minus 1 from that
Why?
because of n itself because you don't want n in it. So then you get 639 and then you subtract it from the 1228.
Yeah. A palindrome is a number which is same from both sides.
Yeah. Probability that it's divisible by 7. Okay. I got 1/5.
Why?
So we can say that like a palindrome is going to be like 1000x time, sorry, not times, plus 100y plus 10y plus x. So then you get that equals to 1001x plus 110y. And then 1001 is divisible by 7, so we don't have to worry about that. But 110 isn't. So the only way for that to be divisible by 7 is if y is equal to 7 or if y is equal to 0. So then you get x has like can be 9 values and then y can be 2 values. X is 9 values because you can't have a 0 there because it's the starting one. So you get 9 times 2 for 18 palindromes divisible by 7. And then the total number of palindromes you can get from 1000 to 10,000 is 9 times 10 times 1, so 90. And then 18 by 90 is 1/5.
Total number of palindromes is how many?
90, because you have 9 number of digits for the first one, 10 number of digits for the second one, and then to make it a palindrome, you only have one choice for the other two.
Okay. Probability will be this by this.
Yeah.
A six digit a six-digit palindrome is chosen at random. Let's call it n. What's the probability that n by 11 is also a palindrome? Try this one, and I'll just give you one more question. Find the probability that a randomly selected divisor of 20 factorial is a multiple of 2000. Write these questions, these are homework. Given
Okay.
that Okay. In the eighth question, this expression has been given. K and N are positive integers and N is supposed to be as large as possible.
Yeah, okay.
These three questions try out before the next class.
Yeah, just give me a sec. I'm almost done copying. Okay, yeah, I'm done.
Okay, we'll probably do a class on the weekend sometime. So just let me know
Mm.
when you are free and we'll do one class over the weekend.
Okay, yeah. All right.
Mm,
All right. Thank you.
Bye.